So here we need to find the angular acceleration, the final angular velocity, the tangential acceleration, and the radial acceleration. So for part A, to find the angular acceleration, we simply take the final angular velocity minus the initial angular velocity divided by the change in time, and this is going to be equal to 1 revolution per minute. Rather, we do know that the initial angular velocity is 0, so we can say omega final, or 1 revolution per minute times 2 pi radians per every 1 revolution. And then we'll multiply 1 minute for every 60 seconds. And then we'll divide this by the time in seconds, 12 minutes. And then we'll say times 60 seconds for every 1 minute. And we are getting that alpha, the angular acceleration, will be equal to 1.45 times 10 to the negative 4th radians per second squared. Now for part B, they want the final angular velocity. So this will be omega final equals omega initial plus alpha t. We know that omega initial, the initial angular velocity, is 0. So this will be 1.45 times 10 to the negative 4th times the total time of 12 minutes times 60 seconds per minute. And this will be equal to, my apologies, it's not 12 minutes, but rather 6 minutes times 60 seconds per minute. And this is giving us 5.23 times 10 to the negative second radians per second. Now, to find the tangential acceleration, we simply take the angular acceleration times the radius. So this will be 1.45 times 10 to the negative 4th times the radius of 4.25 meters. And this will give us 6.2 times 10 to the negative 4th meters per second squared. Now, to find the radial acceleration, this will simply be equal to the omega squared times the radius. So this will be 5.32 times 10 to the negative second squared times, again, 4.25. And we're finding that the radial acceleration is going to be equal to 1.2 times 10 to the negative second meters per second squared. So that would be the end of the solution. Thank you for watching.